Okay, again, 2 to the a equals c is equivalent to log base 2 of c equals a. Okay? And even in general, for any base b, you just replace 2 with b, and the statement's still true. It has to still be true if these are true, but don't worry about those connections, okay? Now let's just see how this applies. Let's say I know that my principal is 1 plus 1.003 to the 12t times, I don't know, how much money do you want to invest? Let's just say $10,000. Now this is a typical calculation, a very basic calculation. An important calculation if you want to understand financing and you know, what investments do and so forth. And what investments are expected to do. You never know what's going to happen. Okay. So we want to know when the principal is going to be 14,000. So can we write an equation? Okay, well, we can write an equation. This is our principal, and we want it to be 14,000, right? And the bigger t is, the bigger this is going to be. So eventually this will be 14,000. We just have to see when. So we write P of t equals 14,000 means 1.003 to the 12t times 10,000 equals 14,000. Now, what's the first thing I would do if I wanted to solve this equation? I'm trying to isolate t. Now, I'm not going to be able to isolate t, but notice the t is up here as part of the exponent, right? And right here you have the way to solve an equation with an exponent. You just change it to a logarithmic equation and use this. So all I'm saying is, since t's in your exponent, your equation will ultimately be of this form. And you want to get it into this form. So how could I get this into form b to the a equals c? Well, what's a going to be?
1.003.
Where's a?
12t.
Yeah, a's the exponent, right? Where do you see an exponent in this equation? That's an exponent, right? So that's going to be your a. Now, can you identify b? b is whatever's raised to the exponent, right? So what's being raised to the exponent here? 1.003. Okay? So you have to isolate something of the form b to the a, which means you want to isolate 1.003 to the 12t on one side so you can then apply this equivalence. Make sense? Well, it will after we work through an example or two and then you do some homework. Okay? So how am I going to get? The left-hand side of this thing is not in the form b to the a. Why not?
Being multiplied.
It's multiplied by $10,000, right? So how do we unmultiply that side by $10,000?
Divide both
Well, we could eliminate it by just not writing it down, but we know better, right? What now?
Divide both sides by
Yeah, we divide both sides by $10,000. So we get So if we divide both sides here by 10,000, well, we're going to be able to rearrange this to give us 10,000 divided by 10,000, which is just 1. And that's going to leave us with 1.003 to the 12t. And over here, the division is easy. We get 1.4. Then what do we do?
Can you now put it into the form of log?
I'm sorry?
Can you put it into the form of log now?
Yeah. Now you're in this form, you can change it to this form, which is going to give you something you can punch into your calculator if you just use this. Okay? And you're going to need your calculator. This is the first time you've really needed your calculator. But you can't do these logs. You don't know how to calculate them any more than you know how to calculate 2 to the 1/2. Okay? I didn't let you use 2 to the 1/2 because you didn't need it to get the shape of the exponential graph. And we wanted to base those basic graphs on things that you know how to do. Okay? Without relying on the magic of a calculator on which everybody seems to be too reliant. Although you're doing quite well with that. Okay? Okay, so this is the exponential form. So we recognize this as an exponential equation, just like you have to recognize a quadratic equation when it occurs, or you won't know how to solve it. And you'll do something that doesn't work. Okay? It's an exponential equation. We change it to a logarithmic equation. So let's see. Exponential equation. The general form is b to the a equals c, right? And in this equation then, what's a, what's b, and what's c? Okay, it's an exponential equation. With a equal what, b equal what, c equal what? Write it down in your paper, so I'm going to just come around and see if you can identify these. See how much I've got to talk about it. Okay? Just write a equals, b equals, c equals, and write down what each one is. Everybody's paper, we'll give them an idea and have the gist of it. Okay. Just to be sure. What's a? And b to the a equals c. It's the exponent, right? What's the exponent here? 12t. We've identified it before, but let's make sure we understand. So it's 12t. Now it's written a little small, but, and b is what? Well, it's the thing the exponent applies to, right? And here that would be, there's the exponent, applies to 1.003. Okay, nobody can read that, but that's what I wrote down, okay? And c is, well, the thing on the other side of the equal sign, which is 1.4. Might be able to read that. Okay? So the logarithmic form of this, with the arrows going the wrong way, is what? It's log. Now we got to put b in here, right? So it's a good thing we've identified it so we don't have to think. We thought when we identified it, right? We've got it written down, so now all we have to do is copy it.
Okay.
But I can't read it, so I'm going to have to think. That's terrible. Well, okay. It's log base 1.003 of, let's say, c. C is 1.4. There it is. And that equals a, which is 12t. Okay? Now we're pretty much done. I mean, eventually, once we get a number for this, we're going to have to divide it by 12, and that'll give us t, right? That'll tell us how many years it takes this investment to grow from 10,000 to 14,000. Okay? Okay, how are we going to calculate log base 1.003 of 1.4? It's on the board. Doesn't mean you know where to look. It's okay if you don't, but anybody want to take a stab at it?
Using the exponential equation?
Can't hear you over the hall, say.
Using the exponential equation?
No, use this. Tells you what log base b of x is, right? It tells you do log of x over log of b. If you like the natural log button better, natural log of x over natural log of b. Okay? So again, we have the equation log base 1.003 of 1.4 equals 12t. And we know that log base b of x is just log x over log b. You've got to get used to that. And all we're saying is you get one log from another by vertically stretching the log function. Yeah, we'll talk about that a little later. Let's just get the technique down for solving the equation. Okay? So log base b of x is log x over log b. How can we put this into the form of log of one thing over log of another? Well, if you read it carefully, you see that that's going to be log of 1.4 over log of 1.003. Just using this. You know, b is what's here, that's your 1.003, right? And x is what's here, that's your 1.4, so you're going to have the 1.4 is going to be here, 1.003 is going to be here, and that equals 12t. So your solution is this divided by 12, which equals this times 1/12, you gotta know fractions. So I keep urging you to review them. So you know all the rules, you can do anything that can be done with fractions. Okay? And you learn it in elementary school and forget it because people put calculators in your heads. You can relearn it. And you need to. Okay. So anyhow, you get this. Make sense? Maybe. Those are the steps. Now you can take your calculator, figure out what this is, figure out what this is, and you've got it.
You too.
Okay? You just take out your calculator, find the log button, calculate this log, put the numbers in, or whatever sequence your calculator enables, and you get the result. Okay? And it's not a difficult process, it just takes practice. I'm going to give you a bunch of problems to translate between logarithmic and exponential notation. That's at least half the battle. Okay? It's important to be able to solve these equations. And it's not difficult if you practice it. Okay? If you don't do about 100 of these, it might stay difficult. Maybe you can get it with 20. I think everybody needs to do at least 20 of them to kind of get it into their heads. If you do 100 of them, they're quick and easy. You might even remember it beyond the test day. Okay? Anybody got a calculator? Anybody want to punch that in? I'm guessing that the answer is around 9.